This question is number 15 from exercise 3.3, which we had not done in the last video, so I'm doing it now. See, the question is very interesting, and the question says, find the number of arranging 11 distinct objects. All the objects are distinct. Taken 4 at a time, you are taking 4 objects from 11 objects. And the most important condition is so that a specified object always occurs, never occurs. So there are 11 objects. So suppose the 11 objects are A, B, C, D, E, F, G, H, I, J, and K. These are 11 objects you have. What happens is, from these 11 objects, you are taking 4 objects and doing the arrangement. But which 4 objects are you taking? See, the 4 objects which you are taking from 11 objects, remember that in those 4 objects, one object is always a specified object. That is, one object remains always the same because it always occurs. So I'm solving right now the case of always occurs. I'm solving the case of always, a specified object always occurs. I'm taking this case. Case A, a specified object. There are 2 cases when the specified object always occurs, and the second case is a specified object never occurs. So specified object always occurs. Okay, so think the specified object is K, for example. So K will always occur in the arrangement. K will always occur in the arrangement. So now the cases will be, see, K has to be always there. So K is always there. Now you can take the other 3 as ABC. So you will have K, A, B, C. Or you can take the other 3 as A, B, D. So K and A, B, D. You see this? K and A, B, E. K and A, B, F. K and A, B, G. You see this? All. See, there will be plenty. Not only that, see now K, A, B, G and so much. So K, A, B, J. Now here I have K and with A, B. You can have K and B, C. So K, B, C, D. K, B, C, D. Now A is not there. And with K, B, C, E, K, B, C, A. Not only that, look at this. In all these arrangements, I'm just trying to get you into the solution. See, in all these arrangements, you notice that K is always the first element. It is always the first. It is always the first. I'm placing K always in the beginning. But there is quite possibility that K is not the first. K is the second. Yes, what you are saying is perfectly correct. You can have K at the second place. You can have K here. So when K is here, there are total 4 objects. So these remaining 3 will be filled by the remaining 10. Then there is a possibility that K is at the 3rd place. So when K is at the 3rd place, what will happen? The remaining 3, 1st, 2nd, and 4th will be filled by remaining 10. Then there will be a possibility that K is at the 4th place. So remaining 3 will be arranged by or filled by the remaining 10, like this. So we are going to have here different cases, and using those cases, we are going to solve the problem. So see here, I will write for such arrangement, for such an arrangement, the specified object can be arranged at any one of the four places. The specified object can be arranged at any one of the four places. That is the I'm being more detailed, I'm being more clear. I'm writing the answer in detail. That is the specified object. The specified object can be first, second, third, or fourth in order. Okay. The specified object can come here. The remaining 10 will be arranged here. The specified can come here, second, it can come here, third, it can come here, fourth, it can come. So I will write this can be done in 4P1, that is 4P1, that is 4 different ways. 4 different ways. See, 4P1, what is NC, what is NPR? NPR is n factorial upon n minus r factorial. So this is 4 factorial upon 4 minus 1, 3 factorial. Now I can write 4 factorial. I can write 4 factorial as 4 into 3 factorial upon 3. See how much you are getting? You are getting 4. 4P1 is 4. This is one way of writing 4P1 as 4. The other way is, see, you could have even written, like if you remember when we say, suppose I have to write 7P3. So how I write? 7 into 6 into 5. What do I say? I say that I will begin with 7, and then I will write 3 numbers in descending order. So 7, 6, 5. So suppose if I have to write 7P2, then 7 into 6. That's it. And if I have to write 7P1, then 7P1 will be simply 7. So likewise, 4P1 will be 4. So we have arranged, see students, we have arranged the specified object in how many ways? 4 ways. We have arranged the specified object in 4 ways. The remaining 10 objects can be arranged in 3 places in 10p3 equals to 10 into 9 into 8, that is 720 weights. That is 720 weights. That is 720 different weights. Therefore, total number of required arrangements. Total number of required arrangements is equal to how much? The total number of required arrangements is 720 into 4. See, 4 and here 720. 720 into 4. That is 2880. This is for the first one, the first case. Now comes the second case. What is the second case? The second case is the specified object never occurs. I will write here. Second case is B. The specified object never occurs. Now see, for the second case, when the specified object never occurs, so as I said, I took the specified object, I took the 11 objects as A to K, and then I took the specified object as K. So in the first case, what happened? That specified object was always occurring. In the next case, the specified object will never occur. So in that case, what we will have to do? The arrangement will take place only from the 10 objects. See, that specified object could be any object. Okay, here just for the sake of understanding, I'm taking that as K. In the 11 different objects, it could be any object. So that specified object, if it has not to occur, we will have to ignore it. So I ignored it. So now how many I'm left with? I'm left with 10 objects, and the arrangement will be of 10 objects taken 4 at a time. So what will happen? Since the 11th object is not there, that is the specified object is not there, it will never occur in the arrangement. So how we will write the answer? We will write, since the specified object would never occur, therefore the arrangement will be done from the remaining 10 objects. All right, this can be done in 10p4 different ways. That is 10 into 9 into 8 into 7. That is 72 into 7 into 10. 7 to the 14. 5040 different ways. This is the answer. I hope you all followed it. So we have done quite a bit in permutation, but I must say that there are still plenty of things left in permutation. Like we have to do permutation when some of the objects are identical. See, we have done permutation of objects, permutation. We have done permutation of n objects taken r at a time, r at a time. That is n objects are given and I am arranging these n objects taking r at a time. Suppose I say 7p4. What does it mean? I'm given 7 objects and I'm taking 4 objects out of these 7 objects and I'm arranging them. So this part is 7p4. But then, students, whatever we have done so far, it was all those n objects which we are given. They were all different objects, all distinct objects. They all were distinct. Try to understand this. They all were distinct objects. That is, not a single object was same. For example, suppose I have algorithm. You remember we solved this problem, algorithm. So here I have algorithm. Now there are 9 letters. In these 9 letters, do you find any letter, any 2 letters identical? Do you find any 2 letters identical? No. You have A only once, L only once, G just once, once. See, all are distinct. But suppose I have to make an arrangement of letters of the word. Suppose mathematics. So if I have to arrange the letters of the word mathematics, the scene will be totally different. Why? Because see, M is repeated 2 times, A is repeated 2 times, T is repeated 2 times. You see this? So because of the repetition, it is not going to be the way it is. It is done by us when the objects were all different, all the n objects were distinct. This is one which we still have to do. What is it? So what I'm trying to tell you is we still have to do this part of permutation where permutation of n objects taken r at a time and all the n objects are not distinct. You see this? The n objects are not distinct. They are not distinct. That is, you will find that the given n objects, they are all not distinct. Some of them are identical that we have to still do. Then we have got to do the arrangement of circular arrangement, or you can say circular permutation. That is, till now we had been arranging only in the rows. We had been arranging in orders like this. We had been arranging in the rows here like this. See, one after the other like this. This arrangement, or you can say we had been arranging, like this. One beside the other or one below the other. We had been arranging like this. But what about the circular arrangement? See, there is one kind of arrangement which is known as circular arrangement, That is, the letters or the objects, they are all made to sit in a circle. They are all made to sit in a circle. So this is also, so if I have to arrange, I'm given, say, certain number of individuals, we are given, say, 10 delegates from different companies. of different companies, and they are all sitting for a meeting. Okay, they are all sitting for a meeting around a table. That is a round table meeting. So what I'll have to do, I'll have to arrange them in a circle. I will arrange them in a circle. Now, when you arrange them in a circle, it is not same as the arrangement in a row or in a column when you arrange them in a circle. So even this type of arrangement we have to do, that is permutation in a circle. You call that as circular permutation. Circular permutation. Okay, this also we have to do. But for time being, what I'm doing is, students, see, it is time I teach you a bit of combination, and after I will have done the combination, then I will come back to this kind of permutation. And see, the simple reason for this is, I'm telling you, the reason is I want you to be a bit more matured in the topic. You all must have understood by now that this mathematics, are you using any formula anywhere? Check, tell me this problem. Have you used any very difficult formula or something, very difficult mathematics? Nothing. It is very simple mathematics, but still it is found by some students difficult. The reason is you need to be matured in order to be thoughtful. A student needs to be thoughtful in order to solve these problems. Okay, so I'm stopping it bit here because I want you to be a bit more mature in the subject, and that we can achieve by solving some elementary problems on combination. So I'm starting with combination. Okay, what have we done? We have done permutation. What is permutation? Permutation, the other name is arrangement. Permutation is a mathematical name, the other name is arrangement. And what are we doing in permutation? See, if I'm given n objects, okay, in permutation, okay, if n objects are given, if n objects are to be arranged, taking r objects at a time, okay, then we will call it 11, I'm sorry, then we will call it NPR. Then we will call it NPR. We will call it NPR. That is arrangement of n objects taken r at a time. For example, okay, and remember students that in permutation, order of objects is important. It is important or significant. It is important or significant. See, now I give you an example. Suppose I have here 4p3. So 4p3 is, I'm given 4 objects and I have to arrange 3 objects. I have to arrange those 4 objects, taking 3 objects at a time. So what will be the total number of arrangements? The total number of arrangements will be 4 factorial upon 4 minus 3 factorial, that is 4 factorial upon 1 factorial. 4 factorial is 4 into 3 into 2 into 1, and 1 factorial is 1. So the answer is 24. There are 24 ways this can be done. Okay. And you know that this 24, if I give you by the way of example, if I explain this to you by the way of example, so here you have four objects. Say the four objects you have are, the four objects you have are, say, A, B, C, D. And what are you doing? You are taking any three objects, four objects you have, and you are taking any three objects. So how will it be done? It will be like ABC. You check this, ABC. Then you will have ABD. Then you will have ACD. ACB. You will have ADC and ADB. You will have BCD, BCA, BAC, BAD, BDC, and BDA. Then you will have CDA, CDB, CAD, CAB, CBA, CBD. Then you will have DAB, DAC, DBC, DB, DBA, DCB, and DCA. See, you got 24. You have 24 arrangements. Now, you will understand, students, here that when you wrote ABC, look at this. You wrote ABC. Now, with ABC, you have, see, it is not that you got three, so it is done. No. See, you here also you have the same three objects, but look at the order. The order is different. The order is different. And look at this. Here also you have the same three objects. ABC, ACB, BCA, BAC. You check this and then see here. CBA and CAB. So total, it is not that only the objects taken are important. No, it is not that. It is the objects taken and then they are arranged. So when four objects are given and you are taking any three and doing the arrangement, you can understand that the order in which you are putting those objects are important. Now we come to combination. See, in combination, the order is not important. The order is not important. What do I mean? Suppose I write 4C3. Now I'm see here I had written 4P3. I write 4C3. 4C3. Now what is meaning of 4C3? The meaning of 4C3 will be combination of four objects taken three at a time. Combination of four objects taken three at a time. What does it mean? Very simple. Four objects are there. You have to take three objects from those four objects. So let us take ABC. So the first one that I take ABC. Okay. Now after ABC, I take ABD. After ABC, I take ABD. Now I take ACD. I take the ABC, ABD, ACD. Then I will take BCD. And that's it. That is all. See, there are only 4 ways possible. Students, just check. I cannot say, see, ABC and ABD. ABC, ABD. Now, once I write ABC, everything, like here you had written, see, when it was permutation, remember when you wrote permutation, then for ABC, you had also taken ACB, BCA, BAC, CAB, CBA. You remember for ABC, you had these 5 also. In permutation, even these were significant. They were significant, they were important. But in combination, they are not important. They are not important. Why? Because in combination, we are only selecting the objects. We are not arranging. It is only the selection. So how many here? I had got 24, 6 fours are 24, but here I have only 4. I have only 4 such arrangements. So 4C3 is equal to 4. 4C3 is coming as 4. Let me write the meaning of NCR. Okay. What is meaning of NCR? That now I will write for you. So here I write I write here meaning of NCR. NCR is just a number. Just a number. Remember this. What is NCR? Like NPR was a number, NCR is also a number. Remember that. NCR indicates, and NCR means number of combinations of n objects taken are objects at a time. Are objects at a time. Number of objects n. Number of combinations of n objects taken are objects at a time. Now I write the formula. See, formula. NCR is equal to n factorial upon r factorial, n factorial upon r factorial into n minus r factorial. Into n minus r factorial. Now remember, students, that in combination, the order is not important. So here I will write in combination, the order of selection of objects, is not important, is not important. You can copy this now. I hope you followed it. Now, students, I would like you all to watch this, that when it was, see here, what had I written? I had written that, I hope you all must have copied this. In combination, the order of selection of object is not important. Very well done. Now, something that I want you all to note here is, see 4C3, that is combination of 4 objects taken 3 at a time. You got how many? 4 different combinations you got. But do you remember what had happened for 4P3? The same thing when it was 4P3, what you had got for 4P3, you had got 24. Now the question here is that how does it become 24? See, the answer for the question that how it becomes 24 is hidden in 4C3. See, why 4P3 is 24? It is hidden in 4C3. See how? As you know that in combination, the order in which the objects are taken or they are put, the order in which the objects are arranged is not important. Here you are only selecting the object. So you can check here that 4C3, that is out of 4 objects, you selected 3. And then that's it. Now you will not take ABC again. You will not take BAC, CAB, nothing. ABC, that's it. But you remember what happened in permutation? In permutation, this ABC gave you 6 different arrangements. That is, in ABC, you have 3 objects. These 3 objects can be arranged amongst themselves in 3 factorial ways, 3p3. So what happened there was you took 3 objects. Now these 3 objects are arranged among themselves. So what will happen? 3 objects can be arranged amongst themselves in 3p3, that is 3 factorial ways. So the 3 objects that you are taking, it is going to get you 6. It is going to get you 6. So you can understand this will get you 6. Then this will get you 6. This will also get you 6. And this will get you 6. So you can understand 6 plus 6 plus 6 plus 6, or 6 into 4. How much is that? That is equal to 24. So what is happening here? See, the understanding could be developed. The understanding could be developed by simple concept that in 4C3, these 3 objects that you are taking, these 3 objects are once again arranged amongst themselves. When you do that, you will end up getting 4p3. So if I write here 4c3 into 3 factorial, it is 4p3. Yes, it is 4p3. 4c3 into 3 factorial is 4p3. If I have NCR, and now these are objects which I'm taking from N, if I'm not arranging them, then it is NCR. That's it. If there is no arrangement, then it is NCR, then it is combination. But if those R objects are again arranged amongst themselves, so what will happen? Each one of them will be arranged. Each time R objects will be arranged in R factorial ways amongst themselves. You are taking R objects and arranging them. So this will become NPR. So remember, NCR into R factorial is NPR. NCR into R factorial is equal to NPR. This formula also you can write, or simply you can do that even in this where you have written the formula. As you know that n factorial upon n minus r factorial. What is this? What is n factorial upon n minus r factorial? It is NPR. You all know that this part is NPR. This is NPR. So now here what I have, r factorial, I multiply this r factorial, I multiply on the other side, cross multiplication. So what it will become? It will become NCR into r factorial equals to NPR. Please write this formula also. This is also a very important formula. Please write this formula. NCR into r factorial is NPR. Now I have some very important results which I'm going to take one by one. So here I write some important results. Important results. Suppose if I have 4C1, remember 4C1, 5C1, 6C1, every time if you have R value 1, then it is equal to the total number of given objects. This is 4, this is 5, this is 6, and it's very simple to understand. See, if I have here 4 objects, okay, these are 4 objects. One is a pink. I don't know how you see this, but okay, this pink, yellow, green, and blue, right? So if you have these objects, and you have to take one object, you have to get just one object, that is 4C1. You have to get just one object. From these 4, you have to get just one object. So in how many ways you can select one object? You will select P, or you will select Y, or you will select G, or you will select B. See, there are 4 ways. You can select it in just one way. I'm sorry, you have to select just 1 out of 4. You have to select just 1 out of 4. So you can do it in just 4 ways. 4C1 is 4. Remember, students, if you had to select 2, then the case would be different. Then see, you can select PY, or you can select PG, or you can select PB. Okay, pink, yellow, pink, green, pink, blue, or you can select YG, YB, or you can select GB. Now you can select, see, from 4, you can select any 2, you can select it in 6 different ways. Again, the order is not important. PY, YP same, PG, GP same. So you can select it in 6 ways if it is 4C2. But when I write 4C1, it is only 4 possible ways. You have to select just one. You have 4C1, you have to take just 1 out of 4. So you can take P or Y or G or B, 4 ways. If you had 5, then 5C1 is 5. So remember, students, when you have n objects and you have to select, you want the combination of n objects taken one at a time. So remember, NC1 is equal to n. What is NC1 equals to n? So this is result number 1. You will all write it. Please write this. Please write. Now suppose I have 4C4, 5C5, 6C6. That is, I'm selecting all of them. Whatever number of objects are given, I'm taking all of them. Once again, the same example I will take. Suppose I'm given here 4 objects. I'm given here 4 objects, or say 5 objects I'm given. Those objects are red, yellow, green, blue, and violet. Right? Now what I'm doing is I'm taking all 5. Then only I can say 5C5. So if you have to take all 5, in how many ways can you take them? You can take them in just one way. And what is that way? RYGBV. That's it. Because you're taking all 5. So remember, when you are given certain number of objects and you have to select all of them at once, then it can be done in just one way. It can be done in one way. So remember, NCN is equal to 1. I hope you followed it. See, the next one is quite interesting. Suppose I have here 4 objects and I'm selecting none. 4C0. So I'm given 4 objects and I'm not selecting any of them. So how many ways I cannot select any? Previous question is quite mathematical. So those who are mathematically inclined, they will understand this. I'm not selecting any. So suppose I'm given red, yellow, green, orange. I'm given these 4 objects and I'm not selecting any object. So in how many ways can I not select any object? See, in layman's language, those who are not mathematically inclined, they will find it very foolish. They will find it foolish. That, okay, we understand when you are selecting, you are asking in how many ways you can select. But here, why you are asking in how many ways you cannot select? See, students, mathematics is like this only. Mathematics has answer for everything. And when it does not have an answer for something, it is said that it is mathematically not defined. Please understand. Mathematics has answer for everything. And when in mathematics you cannot answer something, you say it is not defined. It is not defined. You must have heard many a times we say it is not defined. And something which is mathematically not defined, it is once again significant. And what is the significance? The significance is mathematics does not work there. Mathematics does not work there. Anyways, so we come to the question here. Suppose you have Mr. You have one Mr. Swami here. Okay, you have one Mr. Swami here, and he has to, this is Mr. Swami, and he has to do this job. What is that job? That he doesn't have to select anyone from these 4. So in how many ways can Mr. Swami do this? In how many ways can Mr. Swami do this? In how many ways can he not select any? In how many ways can he not select any? Think on it and then give me the answer. So I hope you all must have thought over this. The answer for this is 1. So from 4, I can select 0 in one way. Why? Why we call it as one way? Because see, you not selecting any is the way. You not selecting any is the way. It is known as the way of not selection. And the way of not selection is equal to 1. You not selecting is going to be just one way. It is going to be one way. So remember, students, 4C0 is 1. If you have 5C0, you will still write 1. 6C0 is 1. And NC0 is also 1. Remember that NC0 is also 1. So you may also copy this fast.
Yes, sir.
Now we have some more results that I will write and you will have to learn it by heart. See here. So the fourth one is NCR plus NCR minus 1. Okay, before this, I will write here the next. See, NCR is equal to NCN minus R. Remember this. NCR and NCN minus R, they are always equal. And this we use for making the calculation part easier. Suppose I have here 20C17. 20C17. So remember students, 20C17 is same as 20C 20 minus 17, 3. NCR is equal to NC n minus R. Remember, both the numbers are same. Both the numbers are same. I can do this for you. See here. Let me apply the formula for 20C17. It is 20 factorial upon 17 factorial into 20 minus 17, 3 factorial, right? Now let me apply it here. So here what I will get, 20 factorial upon 3 factorial into 20 minus 3 factorial, that is 17 factorial. Are they same? Yes, you have exactly same number, because you know students, NCR formula is n factorial upon r factorial into n minus r factorial. You have exactly same value. So this is also very important. This we use for solving problems. This will make the problem solving easier. Now, how does it make it easy? I'll tell you. See here. Remember one thing, students, that you remember when we were writing, say I was writing 7P4. So for 7P4, I had told you a faster way of getting it without using formula, and that was you will start with 7 and you will write 4 numbers in decreasing order, 7 into 6 into 5 into 4. See, you have written 4 numbers, 1, 2, 3, 4. Why write 4 numbers? Because we have 4 here. So that way, if I have 7P3, what would I write? I would write 7 into 6 into 5. That's it. Now, this shortcut way of writing the value also works in combination. See, if you have 7C4, if you have 7C4, then remember, you will write it as 7 into 6 into 5 into 4. That is, you will write 4 numbers as you wrote for 7P4. But there, you did not write anything in the denominator. But here you will have to write. And what you will write in the denominator? Denominator, you will have to write 4 factorial. That is 4 into 3 into 2 into 1. 4 into 3 into 2 into 1. See, this 4 and 4 cancels. So actual answer is what? 7 into 6 into 5. The actual answer is 7 into 6 into 5 upon 3 into 2 into 1. Okay. And why the answer is coming this way? It is because 7C4 is same as 7C3. So if I have to write 7C3, what would I write? I would write 7 into 6 into 5 upon 3 into 2 into 1. See, we are getting the same thing. So remember, students, if you have 20C14, never go for 20C14. What you will do? You will write 20C6. You will write 20C. 20 minus 14 is 6. Yes, 20C6. And then what you will do? You will write 20 into 19 into 18 into 17 into 16 into 15. You see this? 20, 19, 18, 17, 16, 15. 6 numbers you have written. Divide by 6 into 5 into 4 into 3 into 2 into 1. And now you calculate. Or you don't have to calculate. You can sometimes even leave like this. That is important. The final number is not important. This is important. So NCR is NC. NCR is NC n minus R. very important formula, and how to calculate in a shorter way the value of combination NCR is also important, which you learned here. So now, as you know that NCR is NCN minus R. So here we come across one very important result. That will be result number 5. That will be result number 5. And let me write it here itself. See, the result is if NCR is equal to NCS. Suppose NCR is equal to NCS, I'm given. So by this, what I will say? Should I say that R is equal to S? Yes, definitely R is equal to S. This is one possibility. But you know this. See, NCR is equal to NCS. So one possibility is R is equal to S. But you also know, students, that NCR can be written as NCN minus R. So I can write this equals to NCN minus R. Definitely yes. NCR is equal to NCN minus R. So I can write equal to NCN minus R. Now when you see these two, see, you wrote R equals to S when you saw this and this. So you wrote R equals to S. But now when you see these two, what you will see? You will see that S is equal to N minus R. So there are two possibilities. What? If NCR is equal to NCS, then first one is R is equal to S, and the second one is N minus R is equal to S, and N minus R is equal to S. There are two possibilities. First is R is equal to S, and the second one is N minus R is equal to S. I hope you all followed this. Please copy. Now we have a property of combination, that is property number 6 or result number 6. See here, NCR plus NCR minus 1 is equal to N plus 1 CR. It is equal to N plus 1 CR. For example, suppose you have 7C5 plus 7C4. See, NCR, NCNR minus 1. So NN, the number of objects given are same. So 7, 7, same number of objects given. But in one of these, the number of selection are for R objects. See, from N, here you are selecting R objects. But in the next one, from N, you are selecting how many? R minus 1. That is one less than this, R minus 1. So the same thing is done here. See, from 7 you are selecting 5, and in the next one from 7 you are selecting 4. That is one less than this, So if you have these two, see, the right hand side becomes, what does right hand side become? The right hand side, see, 7 will become 8, and here you will write the bigger one, that is 5. So this is just a formula that NCR plus NCR minus 1, it will come same as this. If I calculate 7C5 and 7C4, if I calculate 7C5, 7C4 and add them, its value is going to be 8C5. Okay, so let me now do this. 7C5, you know, 7C5 is 7C2 and 7C4 is 7C. 7C4 is 7C3. Okay, 7C4 is 7C3. And see, if I apply the same result, if I apply once again on this, if I apply, see what I did, I applied NCR is equal to NCN minus R, 7C5 is 7C2, then 7C4 is 7C3. Yes. Now, if I on these two, if I apply this result once again, so see what will happen, 7, 7, so this will become 8, C, and amongst these two, which one is bigger? 3 is bigger. So 8C3. See what I'm going to get? 8C3. And what is this? What is 8C5 equals to? 8C5 is, 8C5 is 8C, 8 minus 5. That is 8C3. See, same thing you are getting. So this way also you can say that everything is working. So this is proved. I can give you one more example. See, we can have one more example. Suppose you can have one more example here. Suppose you have 10C3 plus 10C4. So what you will do? See, here you have to have difference of 1. Difference of 1 only, right? So what you will write, 10C3 plus 10C4, it will become 11C. And which one is the bigger one among 3 and 4? 4. So we'll write 4. I hope you understood this. I hope you understood this.